So we're going to be going over log properties of expansion and condensing. Okay. So these properties of logarithms. So we're going to let b, u, and v, they're positive numbers, and it cannot be, b can't be equal to 1. Okay. So we have the product property. The product property says that if I have two things, and u and v in mathematics, when we talk about u and v are basically substituted functions. Okay, so instead of writing f of x or g of x here, we can write u and v. So u and v are basically two things that are being multiplied together. Okay, and so if I have in this logarithm two things that are being multiplied together, the product property says that's the same thing if I take the log base b of u and add it to the log base b of v. Okay, so what we can do is we can take this logarithm with base b and separate it into two separate logs and evaluate each one separately. Or it also means that we can have two separate logs with the same base and then put them together. Okay, it goes both ways. Now, there's also the quotient property. The quotient property is just like the product property. The only difference is in our log here, I have u divided by v, and when I separate it, I get u minus v. So it's the numerator minus whatever's in the denominator to split it up. Or same thing, if we're going the other way, if I have two logs with the same base, I can condense them, put them together. If this is subtraction, then it creates a division. It makes sense, okay? Because in mathematics, we talk about we have positive operations and we have negative operations. Addition and multiplication are positive operations where, say, division and subtraction are negative operations. Same thing with squaring. Squaring a number, we consider that kind of a positive operation versus square rooting a negative operation. I mean, think of it in terms of money. If you have a paycheck and they multiply your paycheck by 2, that would be a positive thing, right? Versus if they divide your paycheck by 2, then that would be a negative thing. So you see what I'm talking about? So the positives go together. So the product property, product deals with addition, where the quotient, division, deals with subtraction. So it kind of makes sense the way they're paired together. Okay? Now the third property we're going to be going over today is the power property. And the power property says that if I have some log base b and I have a power sitting on whatever's inside the log, okay, I can then take this power and move it out front. And that's what's happened here. This power moved from the power of u out to the front of it. Okay? Which makes sense because what does a log give us? The logarithm basically gives us an exponent. So this is an exponent to an exponent, basically. So this would be like finding this, whatever this exponent, and then multiplying it by whatever was our exponent. And that's what you do. When you take an exponent to an exponent, you multiply them. So it follows all of our other math rules. Okay? So let's see kind of how these work. Let's do some example problems. Okay? So we're going to use this information. Log base 5 of 3 is approximately 0.683, and log base 5 of 7 is approximately 1.209. Okay? And if you plug it into your calculator, that's what you're going to get. Okay? But I set this up so you won't have to have a calculator on you. So I want you to approximate this. Log base 5 of 3 divided by 7. Okay? I don't know what log base 5 of 3 over 7 is. But what I can do is I can separate it using the quotient property, and I can separate it into its two pieces. So that's what I did. I basically said, okay, since I have this division going here, I'm going to take this 3 over 7 and separate it using the quotient property itself. So I'm going to use the same base on my 2. I'm going to put the numerator first, the denominator second, and I'm going to put a subtraction in between them. And what this allows me to do now is I know what this is. this is that. And this matches that. So I can now say, okay, well, if this is this and that is that, I can actually do the subtraction really easily because I know those values and I can get my answer. Okay? So this is basically why we do these problems this way. Okay, that's why we have these properties. Because sometimes when I have it written as 3 divided by 7, I can't do that really easily. But if I can actually separate it, it makes it a little bit easier on me. Okay? Now, the same thing here. Log base 5 of 21. Okay? I don't know what that is. Okay, I'd have to plug into the calculator. But I do know that 21 is 3 times 7. Which means inside that log I have 3 times 7 now, which means I can use my product property to split it into 2 separate logs, into log base 5 of 3 and log base 5 of 7. And again, since I already have those defined at the top, I can just plug those values in, do a little simple addition, and boom, I get my answer. Okay? So this is basically what this is used for. Alright. Now we're going to use those same values again, but this time we're going to approximate 49. Okay? And yeah, log 49, 5 base 49, is basically log base 5 of 7 squared. 7 times 7. Using the power property, now I could use product property and separate it into an add, but what would be even easier is to use the power property, bring that 2 out front like this, and now, since I know what log base 5 of 7 is, plug that in, and then 2 times that is 2.418. Okay? So again, you could have done this 2 different ways. You could have done this as 7 times 7, or you could have done it 7 squared. So you could have used product on this one, or you could have used the power property. But you can see where these properties actually are going to help us to actually figure out values, or set it up into a way that I can find them easily. Okay? Alright. Let's talk about expanding. Okay, so we can use these properties to also expand them. So like this. Log base 2 of 7x cubed divided by y. Okay, so I want you to expand this out. So basically we're going to be doing kind of order of operations here. So the first thing that I'm going to have to do when I want to expand this is I'm going to have to get rid of that division. Okay, because remember, in division, we have parentheses on top and parentheses on bottom. So before I can separate any of this stuff on top, I've got to deal with this division. So that's where we're going to start. So I'm going to split up my log, create 2 logarithms, both with base 2, using the quotient property, split up the numerator and the denominator with subtraction. So that's my first step. So I split up my fraction into 2 separate logarithms that way. Now, in this first one, the second one, the log base 2 of y, this one, really is not any other expanding I can do. But in the first one, I have 7 times x cubed, which means there is, in fact, multiplication going on there. So I can actually separate that doing the product property. So I split up this logarithm into that one and that one using the product property and separating them with addition. Now the last thing I can do is I have this x to the 3rd power, and I can use the power property to move that out in front and fully expand my logarithm into 3 separate logs with no powers on any of them. And that would be fully expanded that way. And that's my answer. Okay? So basically what we're trying to do here is that sometimes expanding them, not always, but sometimes expanding them like this makes it easier to solve them. And of course, As it sits now, we could, if we wanted to, separate and actually turn each one of these into its exponential form, which would make it a whole lot easier for us to solve it. Okay? Now, it's your turn. So take a minute and look at this and see how you can expand. All right, so for this one, we're going to expand it out using the product property. Now, we actually have all of this being multiplied. So to separate it, now the base is base 10, it's the common log, we don't write it. But we're actually going to separate it all out with multiplication. And this is what you get, log 5 plus log m plus log n. And that's expanded. Try this one. Okay, so first of all, we got to deal with that multiplication. So you're going to use the product property to separate it. And then once you do that, you can actually use the power property to move this 3 out in front of the x. Okay? Now, if it was written this way, if you had log base 5 and this was 2x cubed like that, it would look a little different. Okay, and you'll agree with me, 2 cubed is 8. So if I rewrote it as 2x cubed, when I expanded it, it would actually look like this. So the way it looks when it starts off kind of gives you an idea of the way it's going to look when you finish. Because this cubed is only with the x here, the 3, since this only 3 is here, it's only with that part, with the log with the x here. Because this 3 is with both, outside of both of them, that's why this 3 is outside of both of them. Okay, so the way it's written at the beginning basically gives you a good idea of what it's going to look like further in when you finish expanding. Okay. Alright, condensing. So basically we're going to be doing the same thing, but going the other way. So I want you guys to condense this into one term. Okay? So again, the first thing we're going to have to do is make sure all of our logs match, is we have to deal with this 2 here and use the power property to move it to an exponent. So that's our first step. Okay? Now that I have all of my logs exactly the same, so right here, this log matches now this log and this log. I can use my product and my quotient properties to start condensing those into one complete log. Alright, so the next step is I have to deal with the addition between these two logs and the subtraction here. So normally in order of operations, if we have addition and subtraction, we start from the left and we move right, since they're on the same level. So start with log 6 and log 2 to the second power. Since they're being added, you turn that into one log using the product property. So it's going to be 6 times 2 squared. And then, now we have these two logs being subtracted, so that's the quotient property, which means we're going to take 6 times 2 squared, and we're going to divide it by 3. And there's my log completely condensed now, and 2 squared is 4. 4 times 6 is 24, and 24 divided by 3 is 8. So basically what we've done here is we've taken 3 logarithms and condensed them down to 1. So instead of having to plug 3 of them in my calculator and do that, and have a bunch of rounding errors, we've condensed it down to 1, making it easier for us to calculate. Okay, that's the advantage. All right. So take a minute and condense this and then start the video again to see if you got the right answer. Okay, so again, when I look at my logs, they have the same base, so I can use my properties, but one of them has that 3 in front. Okay, so I got to do that first, deal with the power property for that 3, and I move it to the power of my t. And then using the product property, since we have addition, multiply the 7 times the t cubed. And that is my fully condensed logarithm. Okay. Here's another one. Try it out, pause it, and then see if you get the right answer. Okay, here we go. So the first thing you're going to have to deal with when you're condensing is dealing with anything with the power property. So you're going to move this 3 to the power here, okay, using the power property. Because I have parentheses going on here, I have to do what's inside the parentheses first. So I have to condense these two first using the product property. Then, once I combine those two, then deal with that subtraction and deal with the quotient property. Okay? So when you finish, you're going to get x cubed divided by 4y. Now, if those parentheses were not there, okay, so if you were actually doing this problem and these parentheses weren't here, get rid of them, and you were doing this problem, basically it would be a lot different, okay, because you would do it in order. So you would do this one and then minus this one, the first one. So you deal with these two first, doing order of operations, because you move left to right, and then multiplied by this, which means the y would have been in the numerator. And your answer would have been x cubed y divided by 4. So you got to be careful. The order and the way these are set up makes a difference on when you're going to finish with. So order of operations is still important. And that's your final answer. Okay. Now, the last thing that deals with properties is our change of base formula. Change of base formula, basically what you can do is you can rewrite a logarithm to change your base. So if you have a really weird base, you can change it into either the common log or the natural log if you want. Okay, so it says that basically if you have c as your base and u, whatever is the base goes on the bottom. So c goes on bottom, u goes on the top, and then you can pick whatever base you want to pick. Okay, b can be anything you want. Can be anything. This and this can be whatever you want as long as it's the same on the top and the same on the bottom. Okay? So, for instance, if I use, say, base 10, it's going to be log u over log c. So this is what it would look like if you used change of base and you chose b or your base to be 10. Versus if you did it and you use base e, which is the natural log. You would get the natural log of u over the natural log of c. Okay? So it's just a way to change the base so that it makes it easier on us. Now, part of the reason it makes it easier is because a lot of, especially scientific calculators, don't have a way to change the base. They only have either base 10 or the natural log on them. So we would often have to use this if we were trying to calculate something in a base that our calculator couldn't handle. Now, most graphing calculators nowadays allow you to put in a log of any base. But again, when we were creating this math and creating these formulas, it was before we even had calculators, period. So again, they'd have to go to either some kind of table or some kind of, they'd have to use a slide rule to find those values. So it was much easier to use base 10 or base E than some random base. So one just basic example would be something like this. Use the change of base to evaluate this. And going back to those numbers that we used earlier, I could, if I wanted to, change this completely to say base 5, because I already have log base 5 of 3 and log base 5 of 7. I know what those values are. So I can just using a change of base, say, oh, I want to use base 5 for both of them. So I put the 7 on top, log base 5 of 3 on bottom, and since I already know those values, I can just plug them in, and my calculator can definitely do that really easily. Okay? Or, say base E. Same thing. I get natural log of 7 over the natural log of 3. Now that definitely the calculator will have to do, which is 1.77. Okay? And again, this is just so that we can use either values that we know already or something that we can plug into our calculator a whole lot easier if we need to. And those are your basic log properties.